Hello everyone, myself Shahista Begum, and today I'm going to explain you about credit card fraud detection project. So these are all the contents which I'm going to explain you in this video. From the moment the payment systems came to existence, there have always been people who will find new ways to access someone's finances illegally. This has become a major problem in the modern era, as all transactions can easily be completed online by only entering your credit card information. Even in the 2010s, many American retail websites users were the victims of online transaction fraud right before two-step verification was used for shopping online. Organizations, consumers, banks, and merchants are put at risk when a data breach leads to monetary theft and ultimately the loss of customers' loyalty along with the company's reputation. Unauthorized card operations hit an astonishing amount of 16.7 million victims in 2017. Additionally, as reported by the Federal Trade Commissions, the number of credit card fraud claims in 2017 was 40% higher than the previous year's number. There were around 13,000 reported cases in California and 8,000 in Florida, which are the largest state per capita for such type of crime. The amount of money at stake will exceed approximately $30 billion by 2020. Here are some credit card fraud statistics. Here is the pie chart which shows you a card fraud losses in 2009 and 2018. What is the difference between ML credit card fraud detection and conventional fraud detection? Machine learning based fraud detection is detecting fraud automatically, real-time streaming, less time needed for verification methods, identifying hidden correlation in data. Conventional fraud detection is the rule of making a decision on determining scheme should be set manually, takes an enormous amount of time, multiple verification methods are needed, thus inconvenient for the user, find only obvious fraud activities. What is credit card fraud detection? Fraud detection is a set of activities that are taken to prevent money or property from being obtained through false pretenses. Fraud can be committed in different ways and in many industries. The majority of detection methods combine a variety of fraud detection data set to form a connected overview of both valid and non-valid payment data to make a decision. This decision must consider IP address, geolocation, device identification, BIN data, global latitude and longitude, historic transaction patterns, and the actual transaction information. In practice, this means that merchant and issuer will deploy analytically based responses that use internal and external data to apply a set of business rules and or analytical algorithm to detect fraud. Credit card fraud detection with machine learning is a process of data investigation by a data science team and the development of a model that will provide the best result in revealing and preventing fraudulent transactions. This is achieved through bringing together all meaningful features of card users, transactions such as date, user zone, product category, amount, provider, client's behavioral pattern, etc. The information is then run through a subtly trained model that finds patterns and rules so that it can classify whether a transaction is fraudulent or is legitimate. The techniques of credit card fraud. Here you can see the table of credit card fraud. Categories are internet services, credit cards, healthcare, television and electronic media, foreign money offer and counterfeit, check scam, computer equipment and software, investment related. These are all the techniques of credit card fraud. And on the right side, a number of reports. How does credit card fraud happens? Credit card fraud is usually caused either by card owner's negligence with his data or by a breach in website security. Here are some examples. A consumer reveals his credit card number to unfamiliar individuals, or a card is stolen or lost and someone else used it, or mail is stolen from the intended recipient and used by criminals. Business employee copy card or card numbers of its owner, making a counterfeit credit card. So here in the statistic it shows number of worldwide non-cash transaction by billions by region 2016 to 2021. When your credit card is lost or stolen, an unauthorized charge can happen. In other words, the person who finds it uses it for purchase. Criminals can also forge your name and use the card or order some goods through a mobile phone or a computer. Also, there is the problem of using a counterfeit credit card, a fake card that has the real account information that was stolen from holders. That is especially dangerous because the victim have their real card but do not know that someone has copied their card. Such fraudulent card looks quite legitimate and have the logos and encoded magnetic strips of the original one. Fraudulent credit cards are all usually destroyed by the criminals after several successful payments, just before a victim realizes the problem and reports it. Credit card fraud detection system and the step to implement AI fraud detection systems. Credit card fraud detection systems. Off-the-shelf fraud risk are pulled from third parties. Example LexisNexis or MicroBilt. Predictive machine learning model that learn from prior data and estimate the probability of a fraudulent credit card transaction. Businesses rules that set condition that the transaction must pass to be approved. Example, no OFAC alert, SSN matches below deposit or withdrawal limit, etc. Among these fraud analytics techniques, predictive machine learning models belong to smart internet security solutions. AI fraud detection system implementation steps. Data mining implies classifying, grouping, and segmenting of data to search millions of transactions to find patterns and detect fraud. Pattern recognition implies detecting the classes, clusters, and patterns of suspicious behavior. Machine learning here represents the choice of model or set of models that best fit a certain business problem. For example, the neural network approach helps automatically identify the characteristics most often found in fraudulent transactions. This method is most effective if you have a lot of transaction samples. Once the machine learning driven fraud protection module is integrated into the e-commerce platform, it starts tracking the transactions. Whenever a user requests a transaction, it is processed for some time. Depending on the level of predicted fraud probability, there are three possible outcomes. If the probability is less than 10%, the transaction is allowed. If the probability is between 10 to 80%, an additional authentication factor, that is a one-time SMS code, a fingerprint, or a secret question, should be applied. If the probability is more than 80%, the transaction is frozen, so it should be processed manually. Requirements for payment fraud detection with AI-based methods. To run an AI-driven strategy for credit card fraud analytics, a number of critical requirements should be met. This will ensure that the model reaches its best detection score. Amount of data. Training high-quality machine learning model requires significant internal historical data. That means if you do not have enough previous fraudulent and normal transactions, it would be hard to run a machine learning model on it because the quality of its training process depends on the quality of the inputs. Because it is rarely the case that a training set contains an equal amount of data samples in two classes dimensionally, reduction or data augmentation techniques are used for that. Quality of data. Models may be subject to bias based on the nature and quality of historical data. This statement means that if the platform maintainers did not collect and sort the data neatly and properly, or even mixed the information of fraudulent transactions with the information of normal ones, that is likely to cause a major bias in the model's results. The integrity of factors. If you have enough data that is well structured and unbiased, and if your business logic is paired nicely with the machine learning model, the chances are very high that fraud detection will work well for your customers and your business. Advanced credit card fraud identification methods and their advantages. Advanced credit card fraud identification methods are split into unsupervised, such as PCA, LOF, one class SVM, and isolation forest. Supervised, such as decision trees, example XGBoost and light GBM, random forest, and KNN. We have covered the basic vision of how machine learning for fraud detection works. Let's now dig deeper into the exact models that makes it possible. Unsupervised machine learning method use unlabeled data to find patterns and independencies in the credit card fraud detection dataset, making it possible to group data sample by similarities without manual labeling. PCA, Principal Component Analysis, enables the execution of an exploratory data analysis to reveal the inner structure of the data and explain its variations. PCA is one of the most popular techniques for anomaly detection. PCA searches for correlation among features, which in the case of credit card transactions could be time, location, and amount of money spent, and determines which combination of values contributes to the variability in the outcomes. Such combined feature value allow the creation of a tighter future space named principal components. LOF, Local Outlier Factor, is the score factor that helps understand how high the chance is for a certain data sample to be an outlier anomaly. This is another of the most popular anomaly detection methods. To calculate LOF, the number of neighboring data points is considered to figure out its density and compare it to the density of other data points. If a certain data point has a substantially low density compared to its close neighbors, it is an outlier. One class support vector machine is a classification algorithm that helps to identify outlier in data. This algorithm allows one to deal with imbalanced data related issues such as fraud detection. The idea behind one class SVM is to train only on a solid amount of legitimate transactions and then identify anomalies or novelties by comparing each new data point to them. Isolation forest is an anomaly detection method from the decision tree family. The main idea of IF, which differentiates it from other popular outer layer detection algorithm, is that it precisely detects anomalies instead of profiling the positive data points. Isolation forest is built of decision tree where the separation of data points happen first because of randomly selecting a split value amidst the minimum and maximum value of the chosen futures. Subsequently, if we have a set of legitimate transactions, the isolation forest algorithm will define fraudulent credit card transactions because of their values, which are often very different from the values positive transactions have. That is, they take place further away from the normal data point in the feature space. Supervised ML method use label data samples, so the system will then predict these labels in future unseen before data among supervised ML fraud identification methods. We define decision trees, random forest, KNN and name base. K nearest neighbors is a classification algorithm that counts similarities based on the distance in multidimensional space. The data point, therefore, will be assigned the class that the nearest neighbors have. This method is not vulnerable to noise and missing data points, which means composing larger data set in less time. Moreover, it is quite accurate and requires less work from the developer in order to tune the model. Extreme gradient boosting and light gradient boosting machine, or a single type of gradient boosted decision tree algorithm, which was created for speed as well as maximizing the efficiency of computing time and memory resources. This algorithm is a blending technique where new models are added to fix the error caused by existing models. Light GBM differs from other tree-based techniques only in that it follows a leaf-wise direction to build conditions instead of a level-wise direction. In general, the idea behind all tree-based gradient boosting-based algorithm is the same. Here you can see the figure of leaf-wise tree growth. To classify a transaction as a fraudulent charge, the result of many decision tree is summarized, whereas every future tree improves its result based on of the errors made by its predecessors. Random forest is a classification algorithm that is comprised of many decision trees. Each tree has nodes with conditions which define the final decision based on the highest value. The random forest algorithm for fraud detection and prevention has two cardinal factors that makes it good at predicting things. The first one is randomness, meaning that the rows and columns of data are chosen randomly from the data set and fit into different decision trees. Say tree number 1 receives the first 1000 rows, tree number 2 receives rows 4000 to 5000, and the tree number 3 has rows 8000 to 9000. The second factor is diversity, meaning that there is a forest of trees that contribute to the final decision instead of just one decision tree. The biggest advantage here is that this diversity decreases the chance of model overfitting while the bias remains the same. Different ML models can be used to detect fraud. Each of them has its pros and cons. Some models are very hard to interpret, explain, and debug, but they have good accuracy. Example, neural networks, boosting ensembles, etc. Others are simpler, so they can be easily interpreted and visualized as a bunch of rules. Example, decision trees. It is very important to train the fraud detection model continuously whenever new data arrives, so new fraud schemes or patterns can be learned and fraudulent data detected as early as possible. Final word is fraud is a major problem for the whole credit card industry that grows bigger with the increasing popularity of electronic money transfers. To effectively prevent the criminal actions that leads to the leakage of bank account information leaks, scamming, counterfeit credit cards, the theft of billions of dollars annually, and the loss of reputation and customers' loyalty. Credit card issuers should consider the implementation of advanced credit card fraud prevention and fraud detection methods. Machine learning based methods can continuously improve the accuracy of fraud prevention based on information about each cardholder's behavior. So these are the references which I have gone through to make this video, and thank you for watching this video.